If they miss that, then they don't have enough fuel to return to Earth. So it's very important that the orbit is captured, and this burn ensures that that happens. So as they get to the moon's gravity pulls the ship round, and it goes into an elliptical orbit, the wide orbit to the left. And every orbit basically is elliptical unless people are involved and can actually calculate and correct it. And this is what they do. They have another burn on the dark side of the moon, and they convert that elliptical orbit into a circular orbit, which is obviously going to prove much easier for the next critical phase. And Aoife is going to explain what happens here.
Once they're in orbit of the moon, it is now time to separate the command and service module, known as the Columbia, and the landing module, the Eagle. So Neil Armstrong and Buzz Aldrin get into the Eagle, and then they separate to go their separate ways. Michael Collins goes around the dark side of the moon on his own in the command and service module, and Neil and Buzz head towards the lunar surface. Shortly after separation, the men rotate the landing module so Michael Collins can inspect it through the window of Columbia to give them the A-OK. You'll see just underneath the landing pads there's lines dropping down. These are sensors to check the surface of the moon. They're assuming they can land on it, but they just need to be sure because they can still abort the mission if the ground is too soft. The landing on the lunar surface didn't go as smoothly as they had hoped. The site chosen to land was the Sea of Tranquility because it was smooth and flat. But as they neared the surface of the moon, Neil Armstrong noticed that they were overshooting this area and heading towards rough terrain with boulders. He took over to fly the landing module manually. All the while he was running out of fuel and getting warnings from Houston. 40 seconds, 30 seconds. And this wasn't the only thing going wrong. The computer was also shouting out obscure alarm codes that they had never heard before. 1201, 1202. A computer engineer on the ground told them to ignore these alarm codes, which were telling them to abort the mission. What had happened was that they had left the rendezvous radar with Columbia on in case of an abort. But because the computers in those days were so primitive, it wasn't possible to switch two things on at the same time. So ironically, this almost led to an abort of the mission. So ignoring the alarms, and with almost 20 seconds left, they landed on the lunar surface. Neil announced, "Houston, Tranquility Base here. The Eagle has landed." So, on July 21st, 1969, the world watched as Neil Armstrong opened the hatch, climbed down the ladder, and uttered his famous words, "That's one small step for man, one giant leap for mankind." The world celebrated, but Neil Armstrong was quickly picking up rocks and putting them into his pockets. These had been specially designed in his spacesuit, so if they needed to jump back onto the ship to go home, if anything went wrong, that they'd bring something back from the moon. It's also worth noting that President Nixon prepared a congratulatory speech to the men, but also had obituaries in his back pocket in case they didn't make it back. The men spent 2.5 hours on the moon. They planted the American flag. They set up a light reflector, which is used to measure the distance between the Earth and the moon to this day. They collected a few more rocks, and they took a few more photos, like a day at the beach, really. This is actually the only photo of Neil Armstrong on the moon, and the big photo of it is of Buzz, but in the reflection of Buzz's visor is Neil Armstrong taking the photo, and he was notoriously shy, and that's the only photo of him that was taken on the moon. After their 2.5 hours, it was time to go home again. And this picture shows them shooting up off the lunar surface. This also didn't go as well as they had hoped. You can see as they take off towards the end of the clip, they'll bank to join Columbia. Now this manoeuvre was done with the aid of a pen. On the way down, they had broken a switch to arm the ascent rocket. So Buzz Aldrin used a felt-tip pen to close the circuit so they could take off from the surface of the moon and get home safely. The next clip shows the Eagle docking with Columbia so they can get home again. Now they're travelling in lunar orbit at 20,000 miles an hour, but relative to each other they're actually moving quite slowly. So they're in space, joining up two ships in order to go home. Now this seems very complicated to you and I, but these men, they were the best fighter pilots, of the best test pilots in the Air Force, of the best pilots. So it seems impossible, but it would be like one of us parallel parking. It's difficult, but manageable. So once they docked with Columbia, they transferred themselves back to Columbia and all their rocks, and then jettisoned the Eagle where it crash lands back on the moon. And now it is time to go home, so Kieran is going to tell you about that.
Okay, thanks, Aoife. So I can use this little example of the command and service module. This is now all that remains to head back. And as you can see, the bell, this bell here, that's the rocket discharge. And so it has the power to accelerate and to get out of lunar orbit and re-establish itself back on a path to Earth. It does this by burning on the back of the moon, on the right-hand side of the moon, to give it an extra little bit of thrust, just to break the moon's gravity and to start falling back towards Earth. And after about 60,000 kilometers, which is a very short distance by comparison with the whole journey, Earth's gravity starts to pull it back and accelerate it back. So they travel back, doing various checks, and it comes at this stage to a very, very significant stage. This machine is travelling at over 20,000 miles an hour, and yet it needs to now decelerate slow enough so a parachute can bring it back gently down onto the ocean, the Pacific Ocean. And this is another really critical phase of the mission. And this causes them to check and recheck and double check their calculations and do one final burn to correct their trajectory back to Earth. Because the only way they can convert all of this energy, all this speed, the only way they can get rid of it is to convert it into heat. And they do this by injecting the capsule into the Earth's atmosphere at a precise angle. They won't be going into orbit, they've one shot at this. If they go in too shallow, they'll skip off into orbit, and if they go in too steep, they will probably burn up. So they do all the checks, establish a few corrections, and they discover that they are bang on target, the figures are looking good, the trajectory is right, and then they go for the next slide here, which you'll see, they separate. So you can see the cone at the top has no engines, it has power, and it has thrusters, so it can maneuver itself, but it cannot change direction. And using these thrusters, it aligns itself to the right angle, and on the next slide you'll see that angle is with the blunt end of the capsule down. This is where the heat shield is. And as they pass through the air, converting all that speed into heat, into hot gas, hot atmosphere, the ionization of that air cuts off the radio system. So nobody on the ground or nobody on the ships waiting for them knows whether they've made it or not. And the question is, have they maintained the right orientation, or did they burn up? Or did part of the system overheat and damage the parachutes? Did the parachutes open? And the only time they know this is when the people on the surface see 3 good chutes. And therefore they know all those previous problems have passed away without any issues, and the craft is now floating gently down into the sea. So they're picked up, they're brought back to the aircraft carrier, and that's pretty much mission accomplished. They did what Kennedy 9 years earlier said, landed a man on the moon and returned him safely to the Earth. So that was the Apollo 11 mission completed. But what was it all about? If we look at the next slide, they went to the moon and they came back. They brought back some rocks. It was like a day at the beach, as Aoife describes. And yet the entire mission cost almost the Irish national deficit now. So it was a lot of money. Ironically, this was one of the really important parts of the Apollo program. We all know about satellite phones and GPS and satellite TV and all of those wonderful goodies that we have now and take for granted, which are a spin-off from this intense engineering activity. But this particular painting, and I had one hanging on my bedroom for years, this created in many people of my generation this picture of the Earth as a small globe floating, a beautiful globe, like a pearl, floating in a very hostile universe. And that has encouraged the environmental movement and other movements that have really changed the way we view our planet. But finally, there's one last slide I'd like you to see, and before we look at it, I just want to get a picture of the relative positions of the planets. You see Saturn up there in the top left. Voyager 1 in 1990 was out by Saturn, and Carl Sagan asked that it turn around and take a photograph of the Earth. This wasn't planned. And it did, and this is the photograph. And now the light there that you see, the streaks of colour, are simply just refraction in the glass and the perspex on the spaceship. But if you look at the top one, the brown one, you see a little white dot. That is us from 6 billion miles away. And that is that's a photograph from within our solar system. And if you look at our solar system in relation to our galaxy, it doesn't exist, it's too small to see. And if you look at our galaxy in terms of the cluster of galaxies we're in, it's smaller again. And then there are billions and billions of clusters of galaxies. So it kind of puts it into context. I may feel I'm very important, but to somebody in the next galaxy that may not be the case. But to sum it up, I would ask people to think about, where are we going now in space? Is it possible that people here, and particularly the younger people, will watch in 3D television some stage maybe in 20 or 30 years' time, and they'll hear a voice from the surface of Mars saying, one small step for a woman, another giant leap for mankind.